All right, so we got the first question. Remember, one of these questions is going to be on your test tomorrow, so just running through some extra review here. So, a lighthouse is built on the edge of a cliff near an ocean, as shown in the accompanying diagram. From a boat located 200 feet from the base of the cliff, the angle of elevation to the top of the cliff is 18 degrees, and the angle of elevation to the top of the lighthouse is 28 degrees. So that means if the boat is looking up at the cliff, okay, this angle of elevation from the water up is 18 degrees, all right? So 18 degrees for this. And if you're looking at it from the top of the lighthouse down, okay, this whole angle of elevation here is 28 degrees. All right, and we're essentially creating these two right triangles here as we're going along. All right, they want to know what the height of the lighthouse X is. So from the top of the lighthouse to the bottom of the cliff. And so essentially, we're just trying to figure out the height of these two right triangles. So we want to know what the distance is from the cliff all the way here. And then we want to know the distance that's all the way to the top of the tower from the water. We'll call that T. Okay. And then the difference between those is going to be the height of the lighthouse. All right. So in the first triangle, right, we got a blue triangle here. Okay. We have, and here we'll put it over here for us. We have this triangle, okay, so this is an 18-degree angle. We're looking for C. We know that this is 200, and so this is a right triangle with an angle. So remember, right triangle, yes, it's a right triangle, okay. My two options, Pythagorean theorem, or we have SOHCAHTOA, so we're choosing SOHCAHTOA here. We have our opposite side from C. Our adjacent leg here is 200. And so then we're going to end up using tangent. So the tangent of the angle is equal to the opposite over the adjacent, and then we plug in. Tangent of 18, the opposite is C, the adjacent is 200. I'm going to cross multiply. C times 1, so just C, is equal to the tangent of 18 times 200. I take my calculator. I'll load it up 1 second. All right, and then we're going to simply just type in our tangent of 18. So trig tangent 18 and then times 200. And we end up with that number, and we're going with to the nearest tenth of a foot. So we want to run this to the tenth of a foot, so this is 64.98. So it's essentially, well, you know what, for this aspect, we're going to keep this number as is, but we should be okay rounding it, but we're going to keep it as is. We'll see if there's a difference at the end. So C equals 64.98 and stuff, right? You didn't know you could do that, did you? Except now we just can't see anything. All right, 983939, and we're going to keep going. 2466. All right, and then at the same time, we also have, right, our big triangle. So we have our big red triangle, and this is now T, the height of the tower. This is still 200, but this now has changed to 28 degrees as the angle of elevation. Remember, the angle of elevation is from the bottom looking up. The angle of depression is formed from the guy looking down. But we're always going to take these angles and we're going to put them in this bottom corner because they're congruent. Depression and elevation are equal because they're alternate interior. So we're going to do the same function, tangent 28, okay, is equal to opposite T over the adjacent 200. Cross multiply again. We're going to get T equals 200 times the tangent of 28. Okay, and then we're going to go ahead and type that in. So 200 trig tangent 28. All right, and then we end up with this number right here. Okay, so T is equal to 106.3418863 32, and then we just want to subtract. So we're going to go ahead and take, all right, we're going to go ahead and take the bigger number, and we're going to subtract the smaller numbers. So I'm just going to highlight and hit enter to bring that down, and we get 34 point, and then we're going to round to the nearest tenth, so this is 34.4. Now, had we rounded right away to the nearest tenth, we would have gotten 65.0, because remember the 8 is pushing that 9 up to 10, so we're rounding this up 0.0, and this is 106.3, 6.3, and we still end up with 41.3. But remember, this one rounded up to 4, okay, and it's negative because I put the wrong number first. So minus 65.0, right? And look at, I'm off by a tenth. So we want to be careful here because we lost a point. We're using those whole numbers, not the rounded numbers. Don't round to the end, okay? And so the height of the cliff is just T minus C, okay? So, or the tower, so T minus C, and this is equal to, and we said 41.3, and then units is measured in feet. You say 3 or 4? 4. All right. Second question, diagram below shows the plans for a cell tower, guy wire. Now, if you go outside and look at a telephone pole, okay, telephone pole, and sometimes you'll have a wire that's attached to the pole and then connects to the ground. This wire is called a guy wire, okay? It basically helps keep the pole straight and doesn't fall over. So that's what we're talking about, okay? So the guy wire is attached to the top of the tower. It makes an angle of 65 degrees to the ground. From a point that's located 100 feet from the on the ground. So the point is located 100 feet from where the guy wire hits the ground, and the angle of elevation from the top of the tower is 32 degrees. We also know this angle of elevation here is 65 degrees. We want to find the height of the tower. Okay, so keep in mind, I want to use something to figure out this. Okay, now this is part of two right triangles. So if I can figure out one side in my right triangle here, either one, I can figure out the height of the tower. All right. Now I have 32 degrees, I have a 90-degree angle, but I don't have any other sides in the triangles. What I need to do is find one of these two sides. We can either find this side, okay, or we can find the length of the wire. All right. We're going to find the length of the wire because it's labeled as wire, so I figured it's easy enough. Okay, and to do that, we actually need to use this triangle right here. Okay, and so in this triangle, we know that this is 32 degrees. We know this is 200. This is not a right triangle, so I can't use SOHCAHTOA, can't use Pythagorean theorem. I got to use law of sines or cosines. Okay, now I have an angle and I have a side, but I do have an angle next door. So this angle is just the difference of 180 minus 65. So that's 115. And now I have two angles on the side, so I can use the law of sines here to figure out that side. But if I want to find the length of the wire, I actually need this angle up here. And so if we add 32 and 115 and subtract that from 180, okay, we're going to get 147, and then 180 minus 147 is going to give me 43, and so that's the measure of this angle up here. All right? Nope, that's too big. That's 190, 33. Okay? So 33, and just double checking, right? 32 plus 33 plus 5. Ah! I'm sure that was a crazy noise. There you go, 180. So we're good. Okay. So from here, all right. All right, so what we need to do now is we want to figure out, remember the wire, we'll call that W, okay? So this is angle W. We'll call this G for ground. So this is lowercase g, and this is capital G for the angle. So we're going to do the sine of angle G over lowercase g equals the sine of the W over the big W. Or, oh, that's backwards. Big W for angles, little w's. Okay, so angle G we know is 33, so this is the sine of 33 over, and side G for the ground, remember it was 200. And then the wire we don't know, but we do know the angle is 32, so the sine of 32 degrees over a little w, okay? We cross multiply, w times the sine of 33 is equal to 200 times the sine of 32. And then we're going to divide out both sides, and we'll end up with w, which is equal to 200 sine 32 over the sine of 33. You don't technically have to write that again if you're doing the question. We already have it, but just so we know. Now remember, if we're looking for an angle, I'm going to have to use the inverse. Since this is a side, I'm just going to cross multiply and solve from there. Okay, so 200 sine of 32, and then after it we can hit Control Enter to open up that fraction bar, and then divided by the sine of 33. And we end up with that number right there. Now remember, we're not rounding our answers, okay? But we have a letter for this. This is W, so we can substitute W in, but we want to write down that number again, okay? So, all right, where'd it go? So we get 194.594666919, and that's what W is, okay? All right, I'm going to clean that up real quick, so you hold on a minute, guys. Pausing. All right, the next thing we're going to do is now we have to use our right triangle here, okay? So the right triangle that's here. We now know that this side right here is W, so that's the 194.594666919. We don't want to write that every time, so we're going to leave that, okay? And we want to figure out the height of the tower, and we have this 65-degree angle that we can use here, okay? And so now this is simply a right triangle with two sides at an angle. Remember, right triangle, Pythagorean theorem if I'm looking for another side, right? If I'm looking for the bottom side down here, I'd want to use Pythagorean theorem, okay? Or, not yet. We need the tower first, okay? So since I have a right triangle with an angle measure, I know that I'm going to use SOHCAHTOA. So the tower is the opposite side, okay? W is the hypotenuse. And then we remember from our SOHCAHTOA days that we're going to be using opposite and hypotenuse. So we're going to use SO, the sine, and then remember our formula, sine of the angle is the opposite leg over the hypotenuse. And then we plug in. So the sine of our angle, which is 65 degrees, okay, is equal to the opposite, which is T, over the hypotenuse, which we know is W. And remember, that's that big number right there is what we're plugging in for W. Okay, so if I cross multiply, I get W times the sine of 65 is equal to T. All right, so now we're going to take our calculator. Remember, we already have the last number in there already, right? We already have that 194.594. It's already programmed in our calculator. It's right there. So all I have to do is press the up arrow. Okay, that's Kate. Say hi. You can say hi. You're crazy. Okay, and then we're multiplying it times the sine of 65. So just sine 65, and there's our final answer. So the height of the tower, we want to make sure we're running nearest foot. Next decimal after the first decimal is a 3, so we're going to take it as 176. Okay, and there we go. Okay, feet. That's a feet. That's an FT. Terrible FT, but feet. All right, on to the next question. Our ship, shown below, is heading directly toward a lighthouse whose beacon is 125 feet above sea level. Okay, you can't see it, right? The height right there is 125. At first sighting, the angle of elevation, remember drawn from the water up, is 7 degrees. And then as they move up to point D, it's now 16 degrees. The nearest foot, state determine how far the ship has traveled and the best distance from A to D. Okay? Think about this for a second. Think about how you might go about solving for the length of AD here. Okay? So pause it, think about it. Did you think about it? Did you pause, or are you just waiting for me to tell you? Think about it. All right. So if you had a chance to think about it, we have a right triangle formed from DCB here. We have an angle and a side. So what we really want to do is figure out the length of this side right here. We're actually going to call this X. Okay. If I can figure out this length, that'll help me figure out AD, because the other side over here, I have another triangle. Okay. And in this triangle, here's my 7 degrees, the 125, and I can now figure out the length all the way across from A to C. And so the difference between these two things, X and Y, will leave me with my length of AD. All right, so I'm still using two right triangles. So once again, if it's a right triangle, Pythagorean theorem, okay, or SOHCAHTOA, and since I'm using an angle measure, the 7 degrees, I know that I'm going to use SOHCAHTOA. Now we have the opposite side from Y, the opposite leg, and the adjacent leg. So that tells me that I'm going to be using tangent. So the tangent of my angle, remember, is equal to the opposite leg over the adjacent. The tangent of 7 is equal to 125 over, we call that Y. I'm going to cross multiply, and this time I'm going to get Y times the tangent of 7. And then the last step, I'm not looking for an angle, so not inverse, but I'm going to divide out by the tangent of 7, and we'll have the distance for Y. So on the calculator, 125 divided by trig tangent 7, and hit enter. And so I end up with this number, okay, 1018.0433035. Remember, we know we're not going to round here. So I want this whole number right here as my answer, okay? So let's see if we can copy and paste it in here. And we can, look at that, all right. So there's my number, okay? Except we end here in our calculator with a 5. So there's what Y is, okay? So what we're gonna do, see if I can just drag this. Probably won't let me. All right, we're gonna I'm gonna slide, not that. We're gonna lock this in. Just gonna move this over so we have some more room here. Okay, second triangle. We got the blue triangle, okay? Same deal, a little bit shorter, okay? Same height though, so still 125 feet tall, although not drawn to scale. And now we're looking for this piece, and now our angle of elevation is 16 degrees. So still the same thing, right triangle, have an angle, so I know I'm gonna use SOHCAHTOA, and this time we're gonna do the tangent of 16 is equal to the opposite, which is 125, over the adjacent, we call that X. I'm going to cross multiply again to solve. So X times the tangent of 16 is equal to 125. That's a 6, by the way. Okay. Let's fix that up so it doesn't look crazy. 16 equals 125. And then remember, we've got to divide out to get the X by itself. So the tangent of 16 is what we divide by. And now X is equal to that ratio, 125. And actually, we could just bring this down and change 7 to 16. And there's our number again. So let's copy that. We're going to bring that over here. Okay. And we are at 0.8. And so the answer here, right, the actual height of the tower, or the distance from A to D, is the difference between Y and X. So I'm just going to subtract okay, that 118.04, 33035, and the 435.9, that one. So I go back to the calculator, I'm going to bring down that first number, okay, subtraction, arrow up to the second number, and we're going to subtract, and we're rounding to the nearest foot, so that's 582 feet. Now, we could have possibly rounded to the feet right away and got 436 and 1018. Had we done that, right, we're still going to get the same answer. Just happens that the decimals don't, when we add or subtract the decimals, we're getting that number. We saw last time that there was a problem there. So just be careful that we don't round to the very end. Okay, you can still use your letters that you've designated this. Just make sure if I use Y, I don't have another Y in this question. All right, and the last question, Kathy wants to determine the height of the pole. Diagram below, she uses a survey instrument to measure the angle of elevation at the top of the pole. We got 34.9 degrees. She walks 8 meters closer and does the same thing. We want to find the height of the flagpole. Now we got to keep in mind that our instrument is 1.7 meters above the ground. So at the end, the actual height of the flagpole is going to be that X, right? Which is actually just this distance here. And we have to add 1.7 meters onto it at the end. All right. So we had the same problem we had last time. If I want to find the height of the pole, I need to figure out one of the sides of these right triangles that are forming here. So I have this right triangle all the way across, okay? And then I have this smaller right triangle here. And we're going to deal with this smaller triangle, the non-right triangle first. So in the non-right triangle, okay, we have an angle of 34.9. I have an 8 here, okay? And I need to figure out, and for this question, last time we used the smaller right triangle. This time we'll use the bigger right triangle. So I want to use this right triangle, which has 34.9 degrees in it. And I need to use, and I'm going to find this side right here. We'll call that X, okay? And if I can figure out X, then actually we're not going to use X because we used X for the height of the flagpole. We'll call it Y, okay? So if I can figure out Y, I can use Y to figure out X, okay? This is a shared side here, all right, in our triangles, okay? So that's what we're trying to figure out. So same thing we're going to do this time as before. If this angle right here is 52.8, then the angle next door to it is supplementary. So 180 minus 52.8, all right, is 127.2. And then when I add 127.2 and 34.9 and subtract that from 180, let's see, 17.9, look at that, all right, okay, is the other angle. So this 17.9 is important because it's across from the 8. So remember, in order to figure out this non-right triangle, right, we're going to have to use the law of sines here, okay? Now we're trying to figure out Y, so this is angle Y, and once again we'll say that this is the ground, so G, and this is angle G up here, okay? And we need this 127.2 because we need angle Y here. So our first calculation is going to be the sine of G over G equals the sine of Y over Y, and then we're going to plug in. So the sine of the 17.9 degree angle equals over 8, which is the ground, is equal to the sine of 127.2 over Y. Cross multiply, Y times the 17.9 is equal to 8 times the sine of 127.2. So we'll divide out. All right, and then Y is going to equal whatever we get when we plug in, okay? So 8 sine 127. 0.2 divided by, so control divide for that fraction. Oh, look at, I forgot to get out of that. By the way, control Z undoes that. So, and then we're going to click sign, and we have 17.9, and we get that number. So 20.7323, that's what Y is. Okay, I'm going to slide this over so we have some more room here, maybe. Okay, so Y here, we're just going to move over. Ooh, went red on us. Interesting. All right. And so there is our first answer. We're going to shrink that down a little bit just so that we can save some room. Okay. And now we're in our second equation here. Okay. And just for purposes that we're going to use here, I'm going to make this red. Okay, so that's the first calculation with this triangle right here. So for the second calculation, we're going to use the blue triangle right here. Now we already know that this Y is this 20.7323967,507 number. I don't want to have to write that again, so we're just going to use Y for that. So I have my angle, the 34.9, okay? I have the opposite side and the hypotenuse. And so once again, we're going to bust out with SOHCAHTOA and we're going to use sine. So sine of 34.9 is equal to the opposite side over the hypotenuse, which is that number. Remember, we're plugging that in for Y. Okay. And I get Y times the sine of 34.9 is equal to X. And I don't have to go and type that long number in. It's right here. Okay. So trig. Yeah, I know. I just want the trig. Problem is, the cursor's got to be down there. Trig, sine, right? We said 34.9 outside the parentheses here. Go up and copy and bring it down, and there we go. And we want to go to the nearest tenth, so that's 11.9. Remember, one of these questions will be on your test tomorrow. All right, and I will see you guys then. Part 2. All right, guys, have a great night.